Hey guys, this is the force and motion test. Make sure that you have a calculator and that you are trying your best. It's 15 questions. And just remember you can stop and pause and rewind whenever you feel like you need to. Question number 1. In the classroom demonstration shown below, a rubber ball is dropped to position 1. The ball bounces as shown. At which of these positions does the ball have the greatest kinetic energy and the least potential energy? A, position 1, B, position 2, C, position 3, or D, position 4? Number 2. The capability of a substance to be molded and shaped or hammered into sheets without breaking is known as F, ductility, G, conductivity, H, malleability, or J, luster. Number 3. Mr. Robbins is taking his baby for a walk in a stroller. The amount of force he must use to make the stroller move most likely depends on the stroller's A, direction, B, distance, C, mass, or D, velocity. Number 4. 4 balls made of different materials are placed on a tabletop 2 meters from the floor. Ball A is styrofoam with a mass of 5 grams. B, rubber, 18 grams. C, plastic, 2 grams. D, solid plastic, 21 grams. Which ball has the greatest amount of potential energy? F, ball A. G, ball B. H, ball C. Or J, ball D? Number 5. A student hit a high fly ball over second base in a championship softball game. As the ball rises in the air, it is acted on by the force of gravity. This force causes the ball to A, slow down, change direction, and then speed up until it falls to the ground. B, speed up, keep its same direction, and then slow down as it falls to the ground. C, travel at the same speed until it hits the ground. Or D, travel in the same direction until it hits the ground. All right. Number 6. 4 students were asked to classify the activities of people in the picture below as examples of either potential or kinetic energy. Which student correctly classified the activities? F, girl swimming laps, potential energy. Boy on diving board, kinetic energy. Girl hitting volleyball, potential energy. Boy holding volleyball, kinetic energy. Student 2, girl swimming laps, potential energy. Boy on diving board, potential energy. Girl hitting volleyball, kinetic energy. Or boy holding volleyball, kinetic energy. H, girl swimming laps, kinetic energy. Boy on diving board, kinetic energy. Girl hitting volleyball, potential energy. Or boy holding volleyball, potential energy. And J, girl swimming laps, kinetic energy. Boy on diving board, potential energy. Girl hitting volleyball, kinetic energy. Boy holding volleyball, potential energy. All right, number 7. The graph below shows the motion of a ball rolling on a straight track. What was the ball's average speed during the represented in the graph? A, 0.2 meters per second. B, 0.5 meters per second. C, 5 meters per second. Or D, 10 meters per second. Number 8. A student who was training for a cross-country race jogged for 2 hours and covered a distance of 14 kilometers. What was the average speed of the student? F, 28 kilometers per hour. G, 7 kilometers per hour. H, 12 kilometers per hour, or J, 0.14 kilometers per hour. Number 9, a 55-kilogram student was riding a skateboard to school. He traveled 200 meters in 40 seconds. What was the student's average speed in meters per second? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. So please line up your decimals. Number 10. A student wants to safely be able to move a cart up a ramp onto a truck. To see which ramp would be the most beneficial, the student investigates to see how the length of the ramp changes the amount of force needed to move the cart, measured in newtons. So, the first one's 8 meters, second one's 10 meters, third one's 20 meters. Which of the following conclusions can the student make from the investigation about how to safely move the cart? F, as the height of the ramp increases, the amount of force needed increases. G, as the length of the ramp increases, the amount of force decreases. H, as the length of the ramp increases, the amount of force needed increases. Or J, as the height of the ramp increases, the amount of force needed decreases. Number 11. The archer above shoots an arrow toward a target. Which object has the greatest kinetic energy? A, the archer, B, the bow, C, the arrow, D, the target. Number 12. Which inclined plane requires the most force to push the ball to the top? F, one that's 5 meters. G, one that's 2 meters by 5 meters. H, one that's 3 meters by 5 meters. Or J, one that's 4 meters by 5 meters. Number 13. A cart carrying a brick is pulled up an inclined plane. At which point does the cart have the greatest amount of potential energy? Point A, point B, point C, or D, it has the same amount of potential energy at each position because the mass of the cart doesn't change. Now, number 14. During an investigation, students placed a toy car at the top of a ramp and recorded the distance and time at different intervals. The graph below is a record of their data. What is the average speed of the toy car in the investigation? F, 0.25 meters per second. G, 4.0 meters per second. H, 5.0 meters per second. Or J, 20 meters per second. And number 15. The graph below shows distance over time. Which of these situations could be represented by the graph? A, a student walks for 1.5 kilometers to a friend's house in 40 minutes. The two students then walk another 1.5 kilometers to school in 20 minutes. B, a student walks 1.5 kilometers to a friend's house in 20 minutes. The two students then walk another 1.5 kilometers to school in 40 minutes. C, a student walks 1.5 kilometers to a friend's house in 30 minutes. The two students then walk another 1.5 kilometers to school in 30 minutes. Or D, a student walks 1.5 kilometers to a friend's house in 20 minutes. The two students then walk another 1.5 kilometers to school in 60 minutes. All right, guys, so that's all for the test. Make sure that you bubbled in on your answers, and then you go back and check your bubble sheet, and then you go back and check it again. All right.